Um, Welcome everyone to this system design session. I guess most of the people were here last time, but for anyone who is not here, last time we were talking about location-based searching, and at the end of the meeting, we were discussing how to do the real search. And so this time we are going to continue this location-based session. So in the beginning, I would like to invite Asim to talk about his design using the chord tree.
Sure. I'm also trying to open that link. Do we have the same link which we used last time?
We'll have a different, maybe a different link.
Oh, let me see if I can open the same link from the last time.
You probably not. Let me put the link into the Zoom chat. Wait a second. Chat. Okay, here. And the coder pad link is here.
Let me know when you can see my screen. So this is what we did last time.
Okay, if you want to use the old one, I don't really know the link.
I'm trying to see if I can use it.
Yeah, probably you can. Do you mind sharing the link to in the Zoom chat?
Sure. Okay, here is the chat. Okay, here we go. Okay, I'm also fine to use a new link to what you say. I think, or we can do like a fresh, I think let's do a fresh link only.
Yeah, you can use the
new one.
The new one. This is coder pad one.
Mm-hmm. Okay. Let's continue our discussion from the last time. But I think we have some people who, I think Gaurav joined. Gaurav was not there last time. So Gaurav, just want to give you context what we are doing last time and what we are trying to build here. So basically, we are trying to build a system where I can find nearby restaurants or places. And for that, we were thinking to use this data structure like a quad tree. And first, we also discussed what are the problems could happen if we use like a simple database for this thing. I think we discussed somewhere here. Yeah, so this was where we have discussed, like, if I just use a database, what could be the issues there? Are you guys able to follow me?
Yes.
Okay, cool. So the problem with the database was like I can have something like an ID here, and then could have a longitude, latitude, and something like a name or other thing. If I have to find something based on the longitude, latitude, first I have to find a list based on the, this is a user longitude minus the radius plus the radius. So let's say I'm here, so I'm trying to find everything in my radius. So I'll go to the DB, try to find things between longitude and latitude, and then I have to do a kind of an intersection between them. I can index on longitude, latitude, but when I do an index, that could be a costly operation. And when the database size is too big, I think we discussed about how many places. I think 500 million places. I don't remember, but let's say there are 500 million places in our database. So
Just one thing, I think the problem was that, so if, like, going with the example, if the latitude, longitude is some number, and then if you're doing plus minus radius, we don't know how many latitude, longitude lie, because latitude, longitude, I mean, how much precise we are going. So within that radius, there might be like millions of different latitude, longitude possible, right? So even a simple approach will also not work because we don't know how many those values are. Did you understand? Like it's not mathematical like 500 minus 10 or plus 10. It's latitude, longitude. So there can be many latitude, longitude between a range.
no, but you have longitude minus x and longitude plus x, and you have latitude minus x.
Yeah.
And so you have a range here, and you have a range here.
Yeah.
And then that range could be too big for both of them, and then we are doing an intersection. So that is a costly operation for me.
I think I'm saying something else. So, like, let's take an example. Like, can you search for a latitude? Like, just on your web browser, can you search for a latitude? Some value of latitude and longitude?
You can open maps.google.com. And
yeah, some latitude, longitude.
I think there's a way to pin it. Oh, might be
I think on the top, is it the latitude, longitude?
Yeah.
47 point something, right? Okay,
Yes.
now you're saying I want to search for something within 5 miles of radius. So do you know how many latitude, longitudes are actually possible between those 5 miles? We don't know, right? There might be so many. It depends on how much precise you are going. But if you're looking for latitude, longitude between 5 miles of that, there can be many, right? If you do plus minus 5 to 47, like there can be many values between that.
Yeah, I think we're both saying the same thing. What I'm saying, like when I have a range here and here, then I have to kind of intersect that range. That's what will give my answer. There could be a lot of, the range could be too big for this guy, and when we intersect that range, it becomes more problem.
Okay.
So what I'm trying to say is like we have 1, 2, 3, 4, 5, let's say, and let's say here we have something like again 6, 7, 8, 9, 10. So let's say I am at somewhere at 2, 9, and I'm looking for somewhere I want to go like plus minus 1. So this would give me here, and this would give me something like here. And then I have to find something like an intersection. What could be the intersection between these two things?
You're saying, so 2, 9 are your original latitude, longitude, and you're doing plus minus 1. You're searching for plus minus 1, right? Yeah. So what I'm saying is that, so you might have to search for 2.1, 2.2,
Yes.
2.11, 2.122, which is like lot of searches. So,
Yeah.
yeah, that's,
So basically,
that's what I just want. Yeah.
this will give and this will give me another result set. Then we have to find like, okay, what both find. So now I'm doing like you said, 2.1. So basically I'm doing all kind of searches in my database, like where I get only I get this point, which is kind of within my range. But to find this, I have to go like find all combinations.
Yeah, right.
So that's what I was telling. Like I have to do some. Why
can you not? Why you cannot index by the longitude, latitude?
Because there are two. I don't know how to index both of them. I thought like I can only index this and this.
I think even you index them, the search finally will be a joint operation. Like we can have the query that query the range of the latitude and another query to get the list of the longitude and join them together anyway, even though we are using the index or not. And especially here in this case, the table probably will be 3 columns. One column is the ID, the which store, and one column in the longitude and one column in latitude. So adding the index, I think probably may not be that useful, but it may increase the performance, but may not be very.
One is the primary, one is the secondary. One is the primary index, and the other one secondary index, right?
So you already indexed and you find your results are 1, 2, 3. And from the other index, you already found your results are 8, 9, 10. Now we have to find the combinations where I have a combination in my DB. I only found a 3, 8 combination in my database.
So by index,
you use the same index.
Sorry.
The first index is let's say the latitude, right? And the second index is the longitude. Then when you search, you only search. We use the index. We search for the primary index with the latitude first, and then within that we look for the secondary index. So we don't need to query two. We don't need to run two query and merge them.
So that two queries when the result is big could be costly. So that's what is my understanding.
Is it? So one question, by index, you guys means hash index or this tree index?
Just the range index, a tree. So you can look for the range.
Tree index.
Yeah.
Okay.
Because it within the range, right? You have to be close proximity. It have to within that range.
Yeah.
So I think that's what 1, 2, 3, and that's what I drew last time. 4, 5, 6, and then 8, 9, 10, 11, 12, 13. Yeah. So let's say somebody was at point 312 and going plus minus 1, and that's what so the user, so we are going to find, okay, what are the range for 3 to it would be 2, 3, 4, and for the other guy it would be 11, 12, 13. Now we have to find all the kind of combinations. Do I have a 211? Do I have a 212? Do I have a 213? So index will be able to help you giving this part. how
but
you
why can you run query to find 211 at the same time? 211,
yeah, so after that
212, and 213 at the same time.
so after that I have to write a query. Okay, look for, do I have a 211 in my database? So the query would be doing something
No,
like
you
this.
find the range,
So that's what I'm telling you. You got two different sets now. You have one set where you have 2, 3, 4, and you have one set 11, 12, 13. Now what you will do, you will have to still run a kind of a pattern to find, do I have 211, do I have 212, do I have 213? Like it could be like an n square operation.
Yeah, seem like I don't think like that is true based on my understanding. Because like latitude longitude is a pair. Okay, so so at like I believe like what Hiran said, like if we have to find like latitude longitude, let's say like latitude between 2 and 4 plus or minus 1. So so we are looking for 2, 3 and 4, uh, and then like the second index will give us um, uh, the longitude. Okay, so
11,
I believe like one query will be good enough. This concept of intersection looks like
Yeah.
not correct to me. Think of it as a pair, like we are not getting like two different rows and then combining them, because the way like you are describing, let's say we get 12 from the table, but corresponding to that 12 the latitude is 5. Okay, so 5 and 12 we don't want like anything with latitude 5.
So the query would be something like this. Select star from table where uh, lagged in lag minus x. Okay, so this is the range where latitude between lag minus x, lag plus x,
Yes.
and longitude between longitude minus x and longitude, oh sorry, it should be y plus y.
Yes, so correct. Like, so you are looking at the rows which satisfied this condition, like on
Mm-hmm.
both latitude and longitude, not
Mm-hmm.
separately. It's a and condition. It's like not a or condition. If
Yeah.
it's or condition, that the intersection will make sense. But since it's a and condition, you are looking for either you can like look for first the rows which has certain latitude,
Mm-hmm.
and then like the secondary index can filter out like the longitude which has certain longitude, or the opposite, like look for longitude first and then the latitude. Okay, so so that makes sense
Yeah.
the way that you have written the query, but intersection doesn't make sense.
Yeah. And that query is efficient. It's, because it first look for the latitude, and then they filter, the longitude based on the latitude.
So
that, it only query small set of data.
I think I felt like this is a kind of intersection. So
No,
you
this
are having this results and then you have this result and then
Yeah.
you're doing a kind of intersection. That was my
Yeah, yes, I agree. I think that
So
means intersection.
the problem is that so just draw a graph or draw the map for the Earth and divide that. I mean, when you have the latitude, so you see that the whole strip. So all the POI belongs to that latitude. It will this query will read all these in the memory, and then filter put the second filter on top of that. So that's why this query will get slow.
I think there's something I want to share that I just got the data. In California, there are 3 million of small business. So let's say that we have 3 mega of data, and each data may, let's say that 10 bytes. So there are 30, at most 30 megabytes of thing that can fit in the memory very easily. So in this case, I think that's not a.
But we thought like we have the 500 million locations in the DB.
Oh, you're in the 5 million location. That is also.
Yeah, but that's worldwide, but not in the small area, right? Because we look for a small area, and if you think about latitude, right? You have this latitude and you have the radius for the the longitude. That's not cannot be big. It cannot be allowed because you pinpoint it in one some point on the map already. You cannot read everything in.
So the problem, are you trying to explain why do we need a quadry, that this normal database is not efficient? What are we like? What are we discussing here?
I was proposing in that way, but looks like the audience is not convinced that.
No. So I think I explained this. Like the reason why we need a quadry is we don't know the ranges. So let me give a very simple example and a data structure that everyone has used and related to. So for strings, right? If you want to match strings with the prefix, that you are looking for strings with a particular prefix, we use a data structure called try, right? Why don't we use a hash map in that case? So if I have a list of strings, right? And now my query is that I want to search for strings which start with this prefix. In this case, we don't use a hash map because we don't know what, there might be so many possibilities to enumerate for strings that start with the same prefix. There can be so many possibilities to enumerate, and that's why hash map is not a good data structure, because hash map can only help you find if you definitely know that this is the string, do you want to find it or not. Similarly, again here, I'm emphasizing this here, the problem is between this latitude and longitude, you don't know what those values are. Like there are so many enumerations possible based on the exact precision of your latitude, longitude. So a hash map cannot be used because hash map don't know what keys it should enumerate to. And that's why we need a quadry, because like you need a try in the case of prefix matching, here you need a quadry. So quadry will place all the latitude, longitudes which are close to each other, close in the data structure. And that's how you can find the latitude, longitudes which are within that range.
So Abhishek, are you conquering this part? Like when we run this query, there could be lot of latitude, longitude. Like it could be like I can get 1 million places here.
Yeah, exactly. Like how does the database know? Yeah. Yes. It's not integer, right? Your latitude, longitude is not integer. Like it does not have a fixed number of values.
Yes, so like I agree with this, that just making a database query, it will be like a huge query, and that's where like quadry will help to figure out the data quickly, like the nodes which are close to each other. So that I agree with. Yeah.
But for the query, I'm just saying for the query, right? First of all, because it already indexed by the latitude, and then the second the index with longitude. So when we already pinpoint the latitude, we only read the small subset of the longitude because we already index on that. We're not going to bring everything in and then filter it.
I don't know how my understanding is like first it will find that 1 million range here, and then it will find another 1 million range here, and then it will try to intersect it. That was my understanding.
No, that's as if you create two separate query, and then you do yourself. But if we do,
so there would be one index on latitude, there would be another index on longitude, and then based on the index, it will able to give you a range. And here also it will able to give you a range very quickly. And based on that range, now you have to kind of intersect.
Yes, like which is again, as a line is saying that if you make two different queries, then it will like have to go for two different indexes. But since like it's an AND operation, and once you have already pulled in the latitudes, the rows with certain latitudes from the database, that's all you need. Like now from that subset, you just need to figure out the rows which matches the longitude.
Okay. Yes, so that's what I was telling. Like when if you get these results,
if
you get these results, and then you have to find based on this, what you have in your database, a kind of intersection.
So let's say like you need like based on your original example, you wrote like 2 where latitude is 2 and plus minus 1. Okay, so um, latitude was 2 and plus minus 1. So what rows it will get? It will get the rows 1, 2, and 3. Correct?
Yes.
Okay. Then the remaining rows, like we don't need those. 4, 5, and 6 are like not valid for us.
Yeah. So we have this is gone. So
These are gone. Now what you need to do, like from this subset 1, 8, 2, 9, and 310, you need to look for the data which matches your longitude now.
Yes. So let's say in my longitude, I have something like 10, 11, 12,
And 12.
13,
That's
14.
That's it. No, you're not worried about like 13, 14 because
Yes. So let's say I have a I have this subset. So this is gone.
yep.
Correct. Now I have to find, do I have 111 in my database or not?
Yes. So since you already have the rows based on the latitude, so now the only part you are concerned with, like to from this subset figure out like where the longitudes are matching.
So this is an n square operation now.
Yeah.
So that's what I was telling. This is an n square operation.
Yep.
Why the n square?
Why
okay,
not?
So let's think about. Okay, let's think about the database when the index. When the index, right? Index it put together 111, 112, 113 because it already indexed that way.
So
when we get one,
you can have an entry in your database like 2211. But I'm not interested in 2211. My results set will give me 11. But
it should be like a linear operation, like a log, like a n, not n square, I guess, because like since you already figured out these subset of rows, you again need to go through those rows once more to figure out like where the longitude are matching. That's it.
See, Gaurav, I could get 11 from this database entry also, but I'm not interested in 2211. I'm interested in 111. Do I have 111? No.
No, but like you didn't pick up like 2211, no?
No, I didn't pick up. But why I didn't pick up? Because I've checked 111 is not there.
No, like
but Asim, now you have to filter only based on that. You have 1, 2, 3, so you have to filter only from those records.
Yes.
So okay, let's say this radius is m. Still, it will be like an m square operation.
I assume I put something in the coder pad. Can you take a look at that's my understanding how we are going to query this? And it's pretty long. So we can have, we are talking about we are having 2 indexes and do a union. This is what you're talking about?
No, this one is inefficient because it does 2 separate query. It did not take advantage. It does not take advantage of the index because we build the index on the primary and the secondary. But on that case, we say, okay, 111 is going to be together, 112 going to be together, 113, it already do index that way in the database. We don't need to do the filter because it already indexed on the secondary.
Can you read something like what you think, any query that you think is better in the system design? Sorry, the coder path, so we can make it very clear.
Yeah, if you can write a query, that would be great, Leon.
The same query that you have on the other side, I see. You say between only one single query, and then between the latitude between that range and the longitude between that range.
Can you write in the coder
I'm
path?
updating that.
I also got quite confused.
Yes, like the reason is like we can definitely do union, but like union is not an efficient query. So, but we don't need to do union. We can just do the end operation.
If we do the union, then we don't take the advantage of the secondary index we have.
So my understanding of the index is basically a small table with the primary key sorted, like the sorted or whatever, any sorted way, like any sorted as a primary as a index, and with another column pointing to the original table, something like that. My understanding of the index. So it may look like
The index that you can think in this case index, as sorting a pair. The first value and the second value. The first value is the latitude, and the second the longitude. Just sorting that pair.
So there should be two indexes, and another one is longitude and also row ID, and longitude is also sorted. This is my understanding internally how the index should look like. And what we are doing in the query internally, we're querying these two small tables and combine the data together.
So this would be like a query.
Yeah, this is except that this is not table latitude index. This is a real table, the original table. So what I'm trying to say that if we
would
said
think that.
So my understanding that if we are using the index equivalently, it should be like we are querying from these two tables and join the result together.
So in this case, I think only one index. This one you create two separate index. Only one index. The first one is latitude, and the second value is the longitude.
Would you like to write what you are thinking, how the index would look like?
Can I write it? I don't know if I can. How do I write it? Okay. I don't have control over it. But you can, let's say on line number 3, you have a lat, right? An actual lat is long.
Okay. Hey, Leon, Sim put the link in the Zoom chat. Can I go to that page?
So I think we can come back to this later if we get time at the end.
Yeah, okay.
So I don't think this query would be efficient, but meanwhile, if you can get some more data, we could check. But right now, our main intention was to talk about quad tree, not to optimize this query.
Yep, correct. Like so, quad theory, like can I
We okay. Let's check about the quad tree. Like we go literally down here. Okay, so what we have discussed so far, I would have a table where I have some like ID, then latitude, longitude, and name of the place. Now, the concept we are thinking, like, let's start with the one box right now. Okay, so let's say this is one box. We have a lot of items here. And if I represent this as like XY, which represents my long start and end of this range of latitude, longitude. So I can represent all these places in my thing. But then I can put a bar like if any of the section has 500 places, split it. I don't want a lot of places in my one single node. So then we'll split into 4 places. And then everything would have its again X and Y. Are you with me so far?
Yeah.
Then let's say I would start filling places from my table. I would put some places here, put some places here, put some places here, put some places here. And when this, let's say this section exceed more than 500, again, this will split into 4 different sections. And then that places which were here would go somewhere here like this. And we keep on doing like this way. Whenever we reach a threshold, we'll split into another 4 sections. Are you guys with me so far?
Yeah, I think this makes more sense if there are many many points in this area. Yeah, because this data points is mostly static, so we can maybe we don't really need a database to do the query, because you can see that this is you need to jump back and forth to different places. So traditional database or any kind of database may not be very useful in this case. So we can we can store everything in a file using some unified format. So we can say that one file is the main big quad tree, and we have another file pointing to another quad tree, and the row can be like the range and ID. So yeah, I think this is good way.
Okay. And then if my range is, let's say right now this is in one single server, but now I don't want everything into one single server. What different I can do to make it like a shard way? Can I say like North America quad tree would be separate and Asia quad tree would be separate and Africa quad tree would be separate? Same principle will be followed. This will only hold North America places and this will hold Africa places. And if the query of North America will come, it will suffice it. But let's say we have always active users in North America. So this will become like a hotspot. All our queries coming to North America. Or think in that way, North America would have a lot of places. We'll keep on splitting it into small values, and only one section could be traversing, but other sections are not fairly occupied. So we can still do region-based quad tree, but I was trying to say what are the pros and cons. But
another problem I do see here that, I mean, as you already raised that concern, if a particular region has lots of point of interest, so in that way the quad tree will not be a balanced tree.
Yes. Yeah, it won't be a kind of a balanced tree. Yeah,
I think it would be better. It would be better if it's not a balanced tree, right? Because the more dense area, the more node we have there. Because if we want balance, that means that evenly distributed. We don't have even distributed data. We have some area very dense. So the better that we partition it that way.
Yeah, see, so it looks like all your queries will go like this then, if this is not balanced. So your queries will always come here, 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 here. These nodes will not ever be touched.
So if somehow the quad tree reach in that situation where we cannot fit in the memory of one system.
Again, we have to think then. Like
I
say,
think
we are keep on getting new requests for North America. So at some point, this will not able to hold entire places. Yeah, that is another point.
Yeah. Then we split it, right? We split it.
Yeah,
because
so we
it's too
can
big.
have a hybrid approach. First thing is like have a split before only. rather than having region-based quark tree, have one quark, have multiple quark trees which suffice the entire globe. So this is entire globe. This is also globe, and this is also globe. But now what we are doing, we are based on the location ID or something, we are putting it. So let's say this, it could be here. Same similar nearby location restaurant could be here also, could be here also, could be here also. But then we need some kind of aggregation. So
you're kind of like sharding based on the geography location.
yes. So let's say this is Seattle. McDonald's is here also and Subway is here. But when you are in Seattle, when you want results nearby, we'll go here also, we'll go here, and then we say, okay, McDonald's and Subway are your nearby places.
So I'm
But we
thinking
search
about
only within a certain radius.
Yes.
Then
but
why would we go? Why would we go? All the way to different node?
because your data is living here. So when you reach here, you will search in the radius. When you reach here, you will again search in that radius. That's what you proposed just a few seconds before, where you scroll when the North America gets too big, then split into two places.
Yeah. But then if it's not there, then we don't need to search for the other one, right? Within that radius.
How you will know
and let's say
that is not there in the other one? You reached here and you search.
Because let's say we at this point and we say search in 5 mile radius, if there's no McDonald's there, then we just return, empty. We don't need to go, bigger than 5 mile.
No, I'm not going bigger than 5 mile. Let's say what you said few seconds ago. Let's take that thing only. You told split North America into two different servers. How you will split North America? You will split into again based on cities, or you will say North America server 1 and North America server 2.
I think we can treat the whole North America into a big map. So let's say that there's you see from your map there are quarter tree, and we can see the one area contains a lot of
The problem here is the problem was Seattle. Seattle was having so many places. So that's what we did. Like, okay, this half of the Seattle places can live here and half of the Seattle places can live in this tree. This this server.
So I see the only time you need to query, both of them is the user location is somewhere, at the edge, right? At the edge of, let's say.
I don't know.
Then
I don't know. I have half places here. I have half places here of Seattle. So I have to go both the servers and find out. It's as simple as that. That was my design. So, if you have a separate design, we can check around that. But what I'm proposing.
Yeah. So let's say. Suppose I am.
Let me first finish what I'm proposing, and then we can look for a alternate design. Right now, what I'm proposing is half of the Seattle places are here, half of the Seattle places are here, and even some Seattle places are here. I would go to all the servers, get all the places, and then do kind of a union, and then result set to my user. That was my design. Now I'm happy to check what alternate design you want to propose.
I will propose.
Okay, I'm gonna say quickly. So first, I know the location, right? Then I will have the square. I will build a rectangle around the current user location, right? Because let's say I can build a square with 5 mile, and think about that's like a rectangle, right? And I see if this rectangle intersect with the North America too, then I only query that overlap.
Again,
right?
Let me come back. That was a separate design. Right now, I'm checking about where the entire globe is one server. So the design what I'm proposing is in this server is representing the entire globe, not North America.
Okay, but then how do you know, where's your query? Your query have to based on like the rectangle, right?
Yeah, so first I'll go this place,
Like
find
that.
the appropriate node, get the result, go this server, get some results, go this server, get some results, and aggregate it.
No, only when it intercept, then you go there. Why would you go there if it's not intercept?
So that is my design. Like I'm representing this entire globe. So that's what I'm telling you. You have alternate design you can propose, but right now the design what I'm proposing, this is the entire globe.
Can you guys
But
hear me?
wouldn't that with the quad tree? The quad tree, you only look for that intercept only, right? Unless I don't see the quad tree, you have to search for all the global data.
I think, Leon, what Asim is suggesting that, I mean, he splitted that. Correct, Asim?
So what I have splitted the places.
Yeah.
So if Seattle has 10 places, I have put them into 3 different servers. So if Seattle was having 1 to 10 places, so this would have 1 to 4. This would have 6 to let's say 4 to 7, and this would have 8 to 10. Now I would go to appropriate Seattle location and find out the nearby places. Could be this guy would only return me 2, 3. This guy only return me 5, and this guy might not return me anything.
So Asim, what is the reason to split that?
So the reason to split is like now if Seattle has a lot of places, it would split into all the servers. It will not be like in one server staying in. Let's say you are adding more places also. It will so let's say I put 100 new places. Otherwise, it will all go in this place. Now it will again get 100 places could again split, like 20 will go here, 20 will go here, and let's say 60 will go here.
So you are splitting based on that the server capacity, right? Your server cannot hold more than.
You can say server capacity, or it's like a typical way of how we do sharding.
Yeah, you can say like server capacity. Like right now we are just thinking about like maybe 100 nodes, but like think of if we have to put the entire businesses like that are in the Seattle area.
Yeah.
Okay. There can be like million, yeah, including like small shops, big shops, maybe medical offices or whatever. So they can be a lot of places. So it's
Got
like
it.
it's kind of like a way of sharding between multiple, like a way of sharding. So we are splitting it between multiple servers.
And like we like I mentioned, approach 1 and approach 2, it could be a hybrid. It could be like we can try multiple combinations. We could have just North America, and then we could have done the same thing. Just have North America into different servers. Or right now, I'm just saying entire globe. It's up to us, like how we want to do. We can have a region-based shard, and then inside the region-based shard, we can apply this approach too.
So which means that it could be possible that a query will go to only one server only.
Yeah, if you know like you're going North America, then it will go to this server. But now I have put entire data in, like my one server represents the entire globe. So the query has to go all the servers.
That server actually can be duplicated because the data won't change very frequently. So we can distribute that work into different servers, different nodes actually. So we can have multiple nodes represent North America, and the different nodes represent to different areas.
So right now I'm just giving a very simple scenario, like how two things you can shard. After that, we can pick the hybrid model.
I post a link, on the Discord, last week. That was related to the quiet tree. If you go on there and you watch that video, I think it's very clear because each point, I think that each point on the map will represent a business location, right? We already know the longitude, latitude for that, and now we only need, when we query that, we just need to create the rectangle with 5 mile radius and only query the one that overlap with that rectangle. So it goes and it get a small set of data, and that I think that it's gonna be it claimed to be big O of log n to query the data. I think according to Wikipedia.
No, right now, Leon, we are not checking about how to query data. Right now we are checking how to split the data. So
it's the same as when
once
we
your data is split, then querying here would be log n, querying layer would be log n, and querying here would be log n.
Yeah, like this scenario, I believe, like we are talking about where your data is too much to handle by one single node. Okay, so you cannot put like all your the entire quad tree in the memory of like one single node.
And then we are discussing different ways of splitting. One way is distribute across servers, and one way is have it on one single server. Like again, making your region more granular. Like from North America, go to US, then go from US to Seattle, and then keep on having data on one single server rather than having Seattle's data splitting across multiple servers.
Yeah, I think that depends on how big the data set is.
Yes.
Like we have 5 million data,
I think
and
in a real interview, just discuss about the trade-offs and be done. If I am doing a real interview, I will not spend that much time. I'll say, okay, these are the 2 approaches I would be able to do, and then move on. Otherwise, the interview will never end. This is a system design interview, and Quadtree is just a helping hand to define a structure. But interview would expect so many other things like, okay, how your end-to-end system will work. So I won't worry that much. I will give my opinion and move on.
Yeah, I agree.
But would that the quad tree will help us to decide when to split the data?
No, I
because
will
like you say, right? If a
right
lot
now
of
I
data
just
go into
gave
one
my
quadrant
opinion of
and then
two
you
different
split
sharding things. Based on the use cases and on the future needs, I can pick up different ways of sharding. That's it. I won't spend that much time like, okay, what will happen here, and going into too granular details. Otherwise, 45 minutes interview will become like a 2 hours interview.
Yeah, I think that's so far. I think this degree of it's deep enough, and if we want to do even deeper, we can just run some simulation locally and see what's going on. For the interview level, I think this is pretty good.
Yeah. So, and Leon, if you are doing a real-time interview, I'll recommend like never go too much into that. Otherwise, your system design interview will become like a really end-to-end. It won't able to finish.
Yeah, but last week didn't you? I thought we already go through. You already draw the high level how it going. Right? We scrolled up. We see last week we already draw, and how it go from and from
So we never finished the high
begin to
level.
the end.
I think we just if this is the last week, that's it. We couldn't finish high level also. We just went into Quadtree and on into that. That's it. And then somebody also told today they will discuss about.
If you scroll up a little bit, and I see, yeah, is it right here? right here where we.
This was Abhishek who was explaining user hash map. We never ever touch like what is our high level also, because so much things around quad tree. It's good to discuss, but I would say like shelf it where we have a basic understanding.
I think if an interviewer asking about the location-based thing, most likely the thing we want interviewer want to discuss is a quad tree related thing or any other technologies. So yeah. So Asim, do you think that is good enough for the discussion of the quad tree?
Yeah, I feel like this is good enough for a discussion of quad tree. Even
okay.
I would not, if in a real time interview, if somebody tell me to programmatically implement it or just talk about quad tree, I would say like, okay, I'm not expert. I never implemented it. I can
quad
just
tree
tell
is like
you.
a separate interview question, like in itself.
Yeah, just design a quad tree.
Okay. Yeah, let's hold on here. And if for any detail about quad tree, I would recommend you guys to do it. Try to create some simulation about this. And do we have any other approach want to talk about this?
I think somebody signed up for some spatial, some other thing I don't remember. Somebody told like, will come and present it.
Yeah, geospace or someone with.
Yeah,
Oh,
I have
yeah,
one.
GeoHash.
GeoHash, yeah.
Yeah.
So do you want to talk about the GeoHash? We have half an hour, and I don't want to spend too much time on this topic. And next time I want to talk about something different to cool down this. So maybe
can we go over the high level because we didn't go to the high level system, right? The high level flow from end to end.
So
okay.
high level flow for me would be again like, so the request would come, this is our request, and then we'll have our quad trees living here, and then based on the request we'll go to all the things and get the things back. And then I think we discussed like we'll have something like another function, and this would be like our master database from where the quad tree would be getting data, and there would be like an admin functionality to add new fields, and then we will adjust them in our quad tree farm. And if some tree goes down, we need some kind of reverse index to build it back. When I say reverse index, like it would be like a quad tree one has a list of these location IDs. And using that location IDs, I can again go to DB and build it back if this guy goes down.
I think that's very straightforward. Just go to the cluster and to the query.
We have to keep that reverse index somewhere and keep on taking its backup. So if we don't have anything further, I just want to give you kind of a kind of a brainstorm, like how now we can do if you have something like a Uber like application, can I use a quad tree or not?
Oh, what you said? Can you say that again?
Uber or
yeah, this is something I want to share about. So like in this case, if we can you stop sharing and let me share you something?
Sure. I will stop sharing then. But are you going to use a quad tree for Uber?
No. because
Okay.
Uber has a very different approach. So let me share my screen.
One second before you.
I think there will be some issue in that if we go with the
So what I was
Uber-like system.
what I was reading that if we want to use a quad tree for Uber, that is also possible. Only thing is,
how do you
we have to keep on updating it.
Yeah,
whenever,
that's I feel that, I mean, I'm not convinced somehow with that, because
so
the update required per second.
no. So what I was reading was the proposal was update after every 15-20 seconds, and so but you will say that in like 15-20 seconds, how the user will know like where is the driver. So the proposal was that have a driver hash table and have something like a notification a pub sub model for a driver. So once on your map you saw like, okay, all these drivers are nearby, then have a pub sub model based on driver and the customer. So driver one could have customer one and customer two. As soon as so this is as good as the notification service design which we did. So once the customers are registered to some drivers, whenever the driver location change, send a notification to the customer. And behind the scene, after every few seconds, keep on updating your quad tree.
So you're saying that the quad tree will update only after 15 whatever time?
20 seconds, yeah.
Okay.
And that, so generally, if you see in your Uber how it works, when you open your a screen, you will see yourself and nearby drivers. That can come from the quad tree. After that, if they are moving, as soon as you get the drivers, you will register a pub sub model for that. As soon as the customer is open the app and see some drivers, it will get an entry like driver one has subscribed, customer one, customer two has subscribed to driver. As soon as this guy location change, will notify that customer, and the driver real time location you will start seeing it is moving.
Okay.
So that was the thing. Don't update your quad tree so often. Have a whatever thing you think is appropriate, and for this real-time movement, use the notification kind of a model.
Okay.
And then again, the notification model could be in different ways, like a pull model, push model, hybrid model. Again, other things we can check with the interviewer. Like I'm just giving you idea if you get the Uber-like thing, how you can use quad tree there.
Got it.
Once a driver has subscribed, okay, maybe
Oh, Abhishek,
Kiran,
you're back.
yeah, you were saying something.
Oh, you're back.
I'm trying to share my idea.
Yeah.
Okay, sorry, Abhishek, you're telling like.
No, I was just quickly here, and just I'll take 1 minute. I was saying that when the driver and driver has subscribed to a user, then it's easier problem, because then we are just mapped between those two. So whatever you said, publisher, subscriber, we can use that. But the difficult problem is when a user has opened the app and the drivers are moving. So what drivers to fetch,
See,
right?
so when you open the app, whatever the state of your quad tree is, pull that things out. As soon as you
Okay, from the
subscribe,
quad tree, yeah.
As soon as you subscribe, might be the driver was showing here, could be, and now it is somewhere here. As soon as you subscribe, you will be able to find, okay, this is not my guy. This is already gone too far. And then we can remove that subscription.
Okay. Yeah.
So I was trying to say like how you can use a quad tree in a Uber like thing. There could be other ways to solve it, but this is because we solved the Yelp. Just trying to say like how you can extend it for Uber. Easy for me.
We use the same thing.
Okay, I think Heron, you can now pick up. Sorry, I took another 5-10 minutes.
Yeah, can you stop sharing so I can share my screen? Okay, so one thing I would like to share is there's something called the Hilbert's curve. So this curve has a very interesting feature that it can map the two-dimension position into one-dimensional position. So like we have the let me see where I can find the example. So like in this here, we can map the 0, 0. Okay, from here it's 0, 0, 0, 1, 1, 0, 1, 1 into a number from 0 to 3, even though this is from 1 to 4. So in this way, so you can see that if any point that is close in the two-dimensional space, they are also likely they can be very close in a one-dimensional space. So that in this way, when we want to query the nearest thing, like I'm in the, for example, in figure 2, I'm in position of 8. This is, let me see, this is 1, 2, 2, 3. Okay, this is 2, 3. I want to know that who is close to me. I can search 7. I can find this number 7 and number 9. So they are close, and at least it's good enough to pick up the driver from these two locations. So, and do you understand what I'm talking? Even though you go to the figure 3, you can see that even the closest, yeah, if it is close in the two-dimensional space, it's also likely to close in the one-dimensional space. This is a feature of the Hilbert curve. So in this way, what we can do the query that because in the Uber case, we do not need to know that how many drivers who are close to me. I just need to know that is it possible to pick up a driver who is not very far from me. Maybe he's next to another block, and in the Hilbert curve is not very close, so we can ignore him. This is not a big problem in the real life. And I do so, but also you can notice from this curve that sometimes number 3 and number 8 are actually very close, but they are not very close their number is not very close because of the Hilbert's curves problem. And I generated something here that you can see how the problem can be. Let me see. Do I have here? Okay, this is something I created yesterday. So in this picture, if the two colors are closed, means that in the Hilbert curve space, they are closed. So you can see there is in this green area that can I draw something
here? I think I'm understanding correct based on what you said last time, making two-dimensional into one-dimensional.
Yeah.
So when
That's
you say
right.
two-dimensional into one-dimensional, it means like making that longitude, latitude, something like on a single line?
Yeah, single number. So for example, still in this picture, like let me pull my thing here. So that here, can you see that? Am I sharing the right thing? Can you see my coder pad?
Mm-hmm.
So for example, if I have the two space, like in this case, we have 2, 3, this is two-dimensional space. I can map it into what's the number? 288, number 8. And if we have 2, 4, it can map to 9. So in the query, what we can do is select anything, an ID from table where my current table, let's say that my current table is 0, and if it's less, if the ID is less than ID 0 plus 1, and ID bigger than ID 0 minus 1. So because I can convert the two-dimensional number that's a pair into one thing. So this ID can be the primary key, which can be sorted. So getting this number will be really fast compared to the previous query. So this is the benefit of this. So the only problem, as I can show you that in my previously shared thing that.
Yeah, I mean, so does Uber actually use it? Because if a driver is nearby but not of the same color, then I will not see it. And probably there might be drivers near me, but because of this Hilbert curve problem, I might see no drivers, right?
Yeah, that's right. Can I see here? Okay, so maybe the driver, maybe the rider is here. Oh, this color is not very well. Yeah. So I can see what I'm trying to. So that the driver, if the driver is in this cell, they can pick up this driver out. But if the driver in this cell, that can be a problem. That
or even the yellow one also, it won't find.
That's right. So this Hilbert curve is very useful in the Uber case because the Uber driver is constantly moving. So we need to update database very fast, and we also need to query database out very fast. But we don't need the query to be very accurate. So then Hilbert curve can be used in this scenario. So this is the thing I want to share.
Mm-hmm. So, but if we're updating okay, go ahead, Abhishek.
No, I was just saying that the driver should be explained about Hilbert curve, that if you're not finding the passenger, maybe you are not in that color box, so move a little and you might find a passenger.
Yeah, in most of the case, this is system behind the Uber, maybe behind Uber, that try to pair the rider and the driver together. So the driver and the rider may not know each other before this process. So this won't be a problem.
And I think I have seen this also, that sometimes you just move a little and you find a driver. And although you don't move too much, so probably because of this algorithm, because you were not in that same color block, and by moving a little, you have entered that area. And
yeah, that's right. Very likely.
Yeah.
And also, this is something I don't really read through all this, this is something we can see that this is also Hilbert curve is used by the Google S2 library. It seems internally it's trying to use this thing for some application. I don't really know that, but obviously, S2 library map the whole Earth into such a curve. And in the later part, you can see that, or not here. There's a picture map. Okay, here. This is a picture that map the whole Earth into different areas, and each area can be constructed as a Hilbert curve. So yeah, any question for this? This is I want to share.
So
No,
based
it
on
was
the
a
curve,
good explanation.
based on the curve, we split into different small blocks.
Yeah. Yeah, if this is a curve and each line represent one small box. Let me see, we can make it bigger. Oh, it can be bigger. Oh, here. You see that this small.
So, so how the use case will work now?
Hmm?
So as soon as the driver will enter that area or the passenger enter that area, they will see each other.
Who do you mean each other?
So what I understood, like every area is now represented by a color code, like how you show in your picture.
I don't really know what do you mean.
You are showing some previous picture, right?
Oh, I see the picture I generated.
Yeah.
Yes.
So I thought
Let
like
me.
something has to do with the color code. Like, okay, all blue is all this, like say pick any color like yellow that represent some geographical area.
Hmm?
And when driver enter that area and passenger enter that area, they will able to discover each other.
Yes, the driver and the rider will see the driver in
So
this
now
area.
in real time, how this will work? As soon as I enter that area, how I will get to know that I have more drivers or there are passengers there. So basically, how passenger will know there are new drivers coming in, and how and
I don't.
how. Uh-huh.
I don't think because the same query like this will. So let's say that the rider will ask the server that can you pick me a driver who is close to me? So the server will do this to this query to do a search in the
So
table.
how
Let's say,
often has to do every like few seconds or milliseconds?
as long as the rider need the driver, it will do a query.
No,
So
I
this is
open my app. I don't see a rider. I don't see a driver. So every 100 millisecond, I'll keep on querying server.
oh, I see what you're talking about. Yeah, if you open the app and you'll see some driver nearby.
I don't see a driver. First case, I don't see a driver. What should happen next?
You don't see the driver. Yeah, you click on give me a ride, and I assume server will do this query to find the driver nearby.
Okay, like there's a midnight, like at 3 a.m. in the morning. I'm trying to find. There is no driver around, but I know like some driver can come nearby and pick me. So what I'm asking, the app has to make frequent calls to the server to get drivers, or
Yeah,
that's what I'm.
each if you do a ride, you have to pay, so you can do a lot of do a lot of search.
No, okay, I understood your question. Probably let me explain it. So, what will happen is it will be the logic of Uber, and it could auto refresh after
Oh,
some interval. So let's say that interval is 1 second. So then if you haven't found any driver nearby, after 1 second, your app will again refresh and it will do this database query and it will find the drivers. The
yeah, I
advantage
see.
of Hilbert curve will be that because now everything is one dimension instead of two dimension, so those queries will be less expensive. Everything will become less expensive because now it's one dimensional query, 1D query. But it will
Yeah,
keep on auto refreshing after, and it depends on the app. Like you can put whatever logic you feel comfortable based on your business and all, after how long you want to refresh.
yeah, something like that.
But can I get drivers from some other region? For example, I saw that color coding. Is it something like I can only find things from yellow region, or I can get things from pink region as well.
Most likely only the yellow region. So like in this case, if okay, my color is blue. So if I'm here, like in our arena here, this is me, and I probably will pick out driver here. I probably will pick out driver here. I probably pick out driver here, but not here.
So if I'm the edge of yellow,
Mm-hmm.
then if there are drivers in the pink also,
you can't see the pink.
Yeah.
Okay. So what I was saying was,
That's the problem.
So
Yeah,
if
that's
I'm here, and I have a driver here and here, but some driver here, then it will try to map me to this guy.
That's right.
Yeah.
That's correct. That's
I think all these companies could be using multiple algorithm behind the scenes. One could be this, and some other algorithms to optimize it. But yeah.
So yeah, that's the thing. You can only choose whether it's you can query it fast enough or query is accurate enough. So you can't have the to achieve two things at the same time.
So basically, we marked kind of region like, okay, this. Okay.
Yeah. So the good thing that here, let me stop my annotation. So the good thing that in, for example, in this database, this one is refreshed very frequently because driver is moving, and each time it will send up the data, constantly send up the location data into the server. So server will upgrade the database, which could be in the memory, maybe not a big issue. It will update the memory very frequently, changing the current location. So it means that there will be an item deleted and there will be item inserted. So that will be a big pressure if the data is in disk. And how many? So we have less than 1 million people in Seattle area. So I believe putting in the memory may not be a problem. If there's a problem, we can find a different way. But you see, if there are too many drivers will crowd in the street, that will be an even bigger thing.
Okay. Any other comments from the audience?
So far, I mean, looks like, I mean, Uber does not use the quest tree at all.
That's because the Uber driver is moving. So the quad tree, I think it's very good for Yelp business, style business because the business, the stores is not moving, and maybe every month you can refresh the database. So all the quad tree data can be keeping the server node and scale it out very easily. So yeah, so Uber and Yelp is in very, I think not very different, but still different. So yeah, that's my thinking. Any comment? Okay. Yeah, maybe it's already almost 6:30, and if any question, we can just stop here. Okay. And next time we can find, if you guys want to talk anything you want to talk, you can leave the message in the Discord. Otherwise, I will pick up something. I don't know what to talk next time. Okay. Sounds good.
I was thinking to talk next time like S3 like system.
Object storage. Yeah, of course.
S3, how S3 simple storage service in AWS.
What is S3? Like, what is it? A database?
Yeah, no, it's like a object-based blob kind of storage. I think in Azure also something is similar.
It's like S3 is provided by Amazon, AWS.
Yeah, in Azure, do you know, Gaurav, what is a close match? It's like a data lake, or I don't remember.
It's a data lake, I guess. Like they call it Azure storage,
Okay.
Azure data storage.
Yeah, Oracle
So if you
OCI
want to store
simply.
blobs.
Yeah.
But yeah, typically you can store anything there. Like you can have JSON or videos, audios, whatever you want to store. It's like I think it's more like a distributed file system. But S3 has
Not a complete file system, but let's talk about this. I will announce it in the Discord channel, and we can find any document offline.
Okay, awesome.
Okay.
Yeah, makes sense. Yeah.
Okay. See you next week. Bye.
See you. Bye-bye.
Right.
Thank you.
Thank you.
Thank you.
Bye.